Hey, what's happening YouTube? This is Hayes Anderson. This is going to be a video on making an electronics project. So what I have here is a MIDI Thru box that I built, and I'm going to go through the process of building another one of these boxes. Quick disclaimer, I cannot be responsible for anything you do with electronics or what you do out in the garage using saws and drills. You do any of this stuff, you do it at your own risk. I do everything by hand for the most part, so I don't necessarily recommend that you do the same things that I do. You can use any kind of CAD, or you can use other services to build the PCBs for you. Let's start from the beginning. So this is the circuit that I'm going to be using. I'm going to provide a link in the description where I got this from. We're going to have a MIDI signal coming in on what's called MIDI in. The through box is essentially going to copy that signal to 4 jacks in this particular one, but it's also going to need to provide to other boxes that are going to daisy chain to it, up to 16 signals in total. This represents the input. The signal comes in across into an optocoupler. This is used basically to prevent having to ground the MIDI signal to whatever device is coming through. This prevents ground loops that would potentially happen. The optocoupler sends a signal to inverting buffer, which inverts the signal, provides a very clean, robust high and low signal, a square wave coming through, representing the binary data, which I have here represented in hexadecimal, but it's ones and zeros essentially. It's high and low voltage. It goes through one inverting buffer, provides fan out to up to, we're going to see if it can do 20. So next up is a demonstration of a breadboard version that I put together of this circuit. Here is our input coming in through our optocoupler into a hex inverting Schmitt trigger, and then all of these outputs coming out to the LED, and then we have 2 test jacks right here. I'm going to hit play over here on my little SQ1. That's a good proof of concept. We have something that actually works, and I can use this as a reference going forward so that if I run into any problems as I'm putting this together, I still have something to work with. So you start with the schematic, then I highly recommend you go from there to a breadboard version. It is a very fun process in understanding how to translate what you see on a schematic to what you can actually get away with on the breadboard. Once you have a breadboard version, well, now you have a working example. So from here, we're now going to start going to designing and getting this onto an actual PCB. So personally, I find the whole idea of designing something and getting everything to fit on something like this to be very daunting. And it is quite difficult. Most people use CAD software to do this process, and it sort of like does all the hard work for you. The reason why I do it by hand is because I wanted to basically build up the experience in soldering and going ground up and getting some really good experience. I don't regret doing what I've done at all, this particular method, but it's not for everybody, that's for sure. So the only reason why I'm going through all the links to state all of this stuff is because, you know, a lot of people are going to be like, hey, just use software to do that, man. Why are you doing it the hard way? Everybody's using software these days, so sometimes it's fun to just kind of build it by hand. What I have here in third iteration that I drew out for this particular circuit, I start using pencil, so I erase a lot of mistakes, and when I finally get something that seems to work, I'll try to get over to pen. Here I ran into a problem where the actual PCB is to scale larger than the sheet of graph paper that I have available. So I recently just got larger sheets of graph paper, and what I'm going to do is I'm going to redraw this now. And as you can see, I've already started the process. I wanted to show you this before I finished everything though. So once I get something that works on the front, I can now flip it over. I can see what's on the back, and that's the back side where everything's going to be soldered. Here's the back where everything's going to be soldered. So I can now focus on all the connections and where I need to cut traces. I'm able to work with a 2-sided piece of medium that I can also kind of see through just enough to keep my sanity in terms of like the organization and making sure that everything is just right. Okay, I was able to make my copy mostly error-free. I think I have something that I can work with now going forward is like a really good solid blueprint, excuse me. On the back I can see where all of my traces need to be cut, and I'm going to get to that here in a second. Before I do that, however, I wanted to talk about the reason why I chose this particular PCB that I purchased on Amazon a long time ago, and I paid way too much for them. I think it was $8 for the set of 2. And having said that, these are extremely high quality, however. They are the highest quality PCBs that I have because they just turned out to be the perfect size. And on top of that, because they're so sturdy, I have some other models here though that I work with, like this particular size probably would have been okay to fit 4, but there was no room to put anything else. I would have had to have some wires coming underneath it and going to like another PCB, so that's not going to work. This guy, you know, I could fit 3, and in fact I was going to use this size to do this. I could have 3 on here and then some wires coming out the back to go to another PCB. But then I figured out just the way that there's 6 inverters on this Schmidt trigger, you have to kind of think about multiples of that number. It's convenient because we have 1 taken up for the input coming in, and then we have 4 throughs and an LED, so that's a total of 6, and we're using them all. With this particular setup of having 4 and an LED and the input, that adds up to 6, and it's absolutely perfect. This one might have worked, but as you can see, I can't fit 4 across it. And of course, these particular ones, as much as I love them, they're definitely not, you know, I could snap this in half right now. Well, maybe not, but these are very, very flimsy, but they're good for other things, like when I make these particular little daughter board helpers for my breadboards. I got a new package in from Tata, so here we go. I needed to get 2 more boxes. I've got some other things to go with it, a few things that I'm going to need for this particular build. So what I need to do next is I need to get my stencil spray paint onto each one of these boxes. This is the stencil I'm working with. I'm going to use yellow for one, and it's lime green for another. Gloss jungle green and gloss sunbeam. Now that the boxes have been painted, I can start focusing more on the PCBs. This particular PCB fits these 4 MIDI jacks just perfectly. Once I get these soldered in, they're going to be like super stable, and then from here it's just a matter of making sure that this is stable inside the enclosure. Now in the past, what I'm normally used to working with are double-sided PCBs that are, you know, through-hole, double-sided. None of the holes are connected. You have to make all the connections yourself. These are what are called strip board. And the way that they work is they have rails that go all the way across. I believe it's 19 rows. In order to prevent that, what you do is you take a drill bit like this and you literally just carve out the copper trace on top of it. This part is very, very critical because here I do not want to make any mistakes at all. Pretty important not to drill a hole in the wrong place. Let's go over the circuit diagram now. I'm going to have 2 wires coming in here for power. Across the top here is going to be the ground rail. The power is going to go across a diode for protection, just in case. It's good to have a diode across here. It's worth the voltage drop, and besides anyways, I'm going to have a 5-volt voltage regulator right here. So no problem with the voltage drop. Ground is also going to come across as a jumper, which is going to kind of edge on the edge of the board and come to here, across the back side of the PCP. I'm going to have to etch out these traces and then have the wire come across. Once across the diode, we're going to hit this 5-volt regulator, and this is going to provide us with 5 volts at this point here. And we'll get ground coming in across this jumper, and at the same time, this whole rail is going to provide ground for the optocoupler. At this point, we're going to need to cut a trace right here to separate the 5-volt rail from the outgoing signal from the optocoupler. And then after that, the 5-volt rail is going to have a jumper that's going to go down to here to hit this rail, which is going to go all the way across the entire length of the board. It will provide power for the Schmidt trigger, for the optocoupler, pin 4 of each of the 4 MIDI jacks. The input, MIDI in that is, it's going to be connected to a panel mounted MIDI jack. Pin 4 from the input is going to go across the resistor, and pin 5 is just going to go straight in. So across these 2 pins will be my input, and the diode, which is over here, is going to fit right here. And then for pin 5 of each of the MIDI through jacks, we're going to have the 220 resistor come across here, each of the individual outs from the Schmidt trigger. So that pretty much covers what's going on with the optocoupler, with the exception of the output. The output is going to need to have like a jumper wire come all the way across to this pin on the Schmidt trigger, way up here. It would have been nice if I could have reversed these 2 around and lined these up so that this particular output would just come straight into this input, but Once I got this kind of laid out, I kind of got lazy and said, this is a really good configuration, so I'm just going to quit while I'm ahead. So once the signal gets through the optocoupler and over here to on this hex inverter, Schmidt trigger chip, the output is going to come across to this jumper way on the edge down here, but underneath I've left 2 pins unetched. So underneath the chip, this pin is going to connect directly to that pin. And the output then is going to come down here to what I call the data rail. And this is the inverted data rail. So this is the first inversion of the signal. And it's going to go across the length of the board. I'm also going to have a wire that's going to provide one of these coming in and another wire for one of these coming out. The data rail is going to go all the way across here, and then we're going to have 1, 2, 3, 4, and including this one will be 5 inputs. One for the LED, which is going to come out across here, and one for each of these MIDI through jacks. And the way that they work, the signal will come into an input, this one will go into this input, this one will go into that input, and finally this one will go into this input. And don't forget that we already have this output going directly into this input. And then each one of these will get across to a corresponding resistor. So this one will go all the way across, down to here, to pin 5 on this one. Likewise through here, down to here, and then finally to here, and actually finally, the LED coming out. And the LED will have 2 wires, one that's going to be connected directly to the 5-volt rail and coming out across this pin here. And that about does it. So for the back, it's just a matter of making sure that where I need to break the connections, I know exactly where to break it. So that should cover it for going over the diagram. At this point, it's just up to me to make sure that I make no mistakes in etching out the rest of these little traces. So on with the soldering, braving on. I've got my bill of materials here in the physical form. Going over real quickly, I have this is my protection diode. I have my other diode, this one right here. Let's see, this is one of the caps, the 100 microfarad, which will go here. The 104 for here, and then there's a 10 microfarad for that one. My voltage regulator, 220 ohm resistors, my 1330 and my 1820, and I think that's about it. Got my sockets. So I'm going to try something new this time. I'm going to try to use this tack to hold things down a little easier for me. So when I insert these components in, I don't want to really bend the leads too much, and if I do bend them, I want them to go parallel with the actual rails themselves. I found that if you bend them any old way you want to, start to go vertical, cause a solder bridge to happen. Another benefit that I like about strip board is that you get to save your leads, and these leads come in handy with the regular through-hole 2-sided boards. So that took about 90 minutes to complete. All in all, it was a success. At the last minute, I realized I forgot this little red jumper going from here to here. Got that soldered on pretty quickly. I went ahead and did a quick continuity check. Ran into a problem. Turned out that I had a really bad solder bridge on the voltage regulator between the ground and the 5-volt output. Went over to sort of test the continuity around here. My finger touched the regulator. Burned my finger on the regulator. That's how hot it got. I think it's going to be okay, so I'm just going to go ahead and just go forward with it. Also found another problem. This particular resistor, I had a bad solder joint. There was just not enough solder to make the connection between the pin and the rail, so I just reflowed it, added more solder, and that worked. So now that I have everything hooked up, I can test for voltage where I believe it's supposed to be. And we're getting power to what is going to be the inverting hex buffer. And we're also getting power to the optocoupler when it's going to get plugged in. So I can go around, I can test the rest of the signals this way. I can insert a MIDI cable and test for continuity across all the pins, which is pretty much what I'm going to do right now, but it's pretty boring to watch that. So next I'm going to put the rest of the external wires onto this board. I'm going to need 2 wires for the MIDI in coming over here. Going to need 2 wires for the LED coming out here, and then 2 more wires for the jumpers coming out on both sides. They're going to be about roughly the same length as the wires that I already have here for power, because if you can envision the back of the box, I need for these wires to be just long enough that I can open the whole box up in case I need to get inside and do any repair work. So now I'm going to try to test everything before I put it into the enclosure. I have my Korg SQ1 sending MIDI out. That's coming across this pair of alligator clips, black and yellow. I'm going to have the LED coming into this little circuit that I had going earlier, and I'm going to try to test each of the 4 MIDI jacks. And real quick, I just wanted to mention that I really liked this tack to help hold in the components when I was soldering. It's really nice because you put it on and you flip the board upside down, things tend to fall out, as gravity will do. And this does a pretty good job of keeping them in without melting to the board. Okay, I'm going to call that a success, I think. So the next step is going to be putting the circuit into the enclosure. Before we focus on the top part, we're going to focus on the bottom part. The challenge is to get this circuit to be supported on the bottom side of the enclosure box. What I'm going to use are 2 nylon screws and bolts to hold it up, and then I'm going to drill 2 holes in the bottom here, and I'm going to use epoxy to support them. It's not ideal by any stretch, but I think once I get the top enclosure cut out and put on top of it and have the 2 nylon screws supported with epoxy, it will support pretty well as long as I'm pretty careful when I'm plugging and unplugging MIDI jacks. So once I get this into place, I'm going to have to let it set for probably 24 hours to let the epoxy fully set and just make sure that it's going to be as sturdy as possible. And while I'm doing all of that and allowing this to set, I will most likely start working on getting this cut, as well as setting up the 4th board to be complete. Back here in the garage, I'm going to try to attach the circuit to the bottom of the enclosure. These are the nylon screws that I was telling you about, and I have the washers attached to them as well. They are 15 millimeters. They're just the right height. What I've done here is I've put masking tape and I've tried to mark off where they're going to be drilled in with the black circles that you see. So now I'm going to just try to drill in some holes, get these attached in. Then I'm going to mix up some epoxy and I'm going to let it set for about 24 hours if I can. So while the epoxy is drying in the garage, I can talk about what is going to happen with the top of the enclosure. The first thing I'm going to do is I'm going to cut a rectangle for the MIDI Thru jacks. And this is going to be the front face where I can access all the jacks, and hopefully it's going to help to secure them into place and clamp them down. And once that is done, I'm going to drill holes in the back for the DC jack, the MIDI jack, and the switch, and also on the sides for the 1/8 inch jacks that are going to act as the daisy chain. So the diagram that you're looking at now is going to be the enclosure looking at it upside down. The MIDI in jack is going to be here. I'll have an LED, DC jack, switch, and then our daisy chain. What I'm going to need to do is wire up a few wires to this before I wire the PCB to it. I'm going to have a ground coming for both of these. Let me get these out of the way. I'll also have 9-volt rail going that way. Then these will individually attach to the PCB. The DC jack will also be grounded directly there, but its power is going to come across to the switch, and then the switch will power the PCB. And then finally, the 2 MIDI wires will go to the jacks. Okay, change of plans. I think I'm going to drill the holes instead of cutting the front side first. Really, my only reservations for doing that in the past was because of the first build and the risk that I was taking. But now that I've built 2 of these already, I'm pretty confident that this is going to work. So I might as well go ahead and drill the holes while I'm waiting for the epoxy to finish drying. The hardest one is going to be the MIDI jack, and I'll probably do a quick pause before I get to the MIDI jack, and I'll explain once I get there. So let's get drilling. here, the problem is that it's not going to fit, and I don't have a drill bit large enough to get that hole. So what I've got to do instead is I've got to route it out with this rotary tool. So this is going to be a whole lot of fun. That part is never fun. It's pretty grueling. Now I'm going to try to get the support screws in as well as the hole for the LED. So the epoxy has mostly dried, and it's now time to work on the final part of the enclosure, cutting out the front facing panel. In the meantime, while I was waiting for this to dry, I was able to put together the 4th circuit. It should be ready to go fairly shortly. So off to the garage, and it's time to cut out a rectangle. One of the features of these MIDI jacks is they're kind of shaped like the state of Tennessee. So if I can strategically do the reverse of the state of Tennessee on this box, these will fit in nicely and provide a little bit of stability. Now to see if it fits. After I solder all the wires to the inside of the enclosure box lid for the hardware to hardware, I will then focus on soldering the hardware to the PCB circuit, and then I will close the lid. And for FYIY, my first MIDI box has been sitting here the whole time, waiting to make music for this video. Next, I'm going to prep the wires for the enclosure lid hardware. And while I'm at it, I'm also going to prep the wires for the 4th circuit. And next is to solder the hardware to hardware wires to the hardware itself. This really isn't too bad, it's only 5 wires. I can do a quick test for voltage just to make sure that everything is okay. That test seemed to pass okay, so the final step now is to wire the rest of it up, close it up, and do a final test. So let's go over this one last time before we put it together. The current's going to connect to the DC jack here for the current loop, and then voltage will be applied across the switch to the circuit. And from here, we're going to basically just have the MIDI jack is going to be connected with the purple and the blue wire. But if you notice, no ground is going to the MIDI jack coming in. That's all going to be handled by the optocoupler. The LED is going to be connected with this red wire and this green wire. And then finally, these end green wires are going to go to the daisy chain. And the daisy chain can also provide voltage, which is also going to come here to the switch. And when it's turned on, will provide voltage to the circuit. Well, that took a long time. I think the reason why it took a long time is because the camera was in the way. So I would just like to go ahead and say that for all the people that do this on a regular basis on YouTube, my hat's off to you. Because getting in there and trying to do this stuff in a very, 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 very small, tiny spots is very difficult to do when there's a camera. What I want to do next is get the chips off of this breadboard and onto this final circuit. I only ordered 4 of the hex buffers and 4 of the optocouplers just for this project. So what I want to do next is just get these chips off the breadboard, put them into here, and do one final smoke test on this board, and then I'm going to wrap up MIDI box number 3. Well, that one didn't set in very well, but I think it's going to be okay. I'm telling you, man, doing this on camera is very nerve-wracking. All right, that's good. And now to close the lid on this, and then we're going to do a final test. We got it working. For a final test, I'm going to use box number 2 as the source for the new box. I'm going to have the daisy chain coming into the TRS jack. So let's give this a final shot. And that's a wrap. Thank you very kindly for watching. I'll see you on the next one.